Welcome everyone to Open Source Days 2021. It's great to have you. This is the session on OpenColorIO, where we're going to be talking about advancements in consistent color management for VFX and animation pipelines, and what our project has been up to over the last year since the last Open Source Days. Just an overview of kind of what we're going to be talking about. I'm Michael Dolan, by the way. I'm a lead pipeline developer at Epic Games, and I currently chair the OpenColorIO TSC. I'm going to be just giving a project update on what we've been up to, and then I'm going to hand it off, and Doug Walker and Patrick Hodoul will be talking about our latest development efforts on OCIO and the upcoming OCIO 2.1 release. And then Carol Payne will be talking about the new ACES Gamut Compression transform, which was recently implemented in OCIO. And then I'll follow up with an update on the working groups, which have been meeting for the last year. So as a general project update, we've been very busy this last year, of course. And in case you missed it, or you probably heard, in January of this year, we released OCIO v2. It was a huge accomplishment. It was in development for 3 years. We had 3 full-time Autodesk engineers and everyone from the community participating in that. So a huge thank you to everyone who participated. It was a lot of work, and it really couldn't have been done without you. And so that's super exciting. That is included in VFX Reference Platform 2021. And we are continuing to work on it and to fix bugs and improve it. And it's actively being integrated into many of the industry applications that you use, both applications that have already supported OCIO as well as new ones. There was recently a blog post on the ASWF site, which was a project spotlight on the industry support of OCIO v2, and it highlighted some of the applications that are actively working on OCIO v2 integration. Some of those, again, are updating and some are new. Autodesk Maya and Arnold currently support OCIO v2. There was also announcements from Adobe that Photoshop, Premiere, and After Effects would be receiving OCIO support. Epic Games is planning on continuing to support OCIO and Unreal Engine. Also Foundry in their new Canuck Studio, CineSync from F-Track, and Houdini from Side Effects. And there's many other applications that are working on integrating it that aren't listed here, but basically you can be excited this upcoming year to see more and more of the products you use be able to leverage the OCIO v2 features that are now available. And for those who are app developers working on any of these applications, or perhaps you haven't implemented OCIO yet, but you're interested, if you're participating in Siggraph this year, we participated a long course. So it's a 3-hour course and an in-depth look at OCIO v2, where we talk about the motivation and the background behind the OCIO v2 project, as well as its architecture, a look at the API and some code examples, as well as some guidelines and tips for implementing it into your applications. So that's for those participating in Siggraph. That's, I believe, available now to be viewed. And we have a Q&A session next Monday where we'll be able to answer questions and talk more about that content. And just some general stats since the last open source days a year ago. You can see on this GitHub graph that we've been very active, and there was 161 commits last year by 22 contributors, which is awesome evidence that the project is in a very healthy state. Again, big thanks to the community, also to the ASWF for really helping to keep the project healthy and going. We had 74 issues closed this past year, and there's of course plenty more to do. And so if you're interested in being involved, there's a lot of opportunities to participate in OpenColorIO, and your contributions are very welcome. You can browse our GitHub repository issues for opportunities to help. We do tag issues with good first issue if they're a good starting point for new contributors, whether you're new to open source software in general or just new to OpenColorIO. Those are great places to get started. You can also join a very active conversation that happens in our Slack workspace and our mail lists. And we have regular public meetings on Zoom. So we have now alternating what meetings we have on each week. So we have our technical steering committee meetings one week, and then we have our working group meetings the next week, both on user experience and our config working group. I'll again be talking more about those shortly, but there's lots of opportunities to get involved, and yeah, we love to have your participation. And with that, I'm going to hand it off to Doug and Patrick.
Thank you, Michael. Hi, I'm Doug Walker. I'm technology lead for color science at Autodesk, and I'm joined with my colleague Patrick Hodoul, who's on the Maya team and who is the development lead on the project. I'm going to run through these slides, and then Patrick and I will both participate in the Q&A session at the end. So we've been very busy on a couple of releases that we're planning on rolling out this month. So first we have a 2.0.2 release that will roll up all the bug fixes since 2.0.1, and we'll also introduce a test kit for the Academy ASC Common LUT format, or CLF, that is being used by the ACES CLF Virtual Working Group. And then we'll have a 2.1 release, and this will be an ABI changing release with new features that I'll talk about in a moment. And 2.1.x is what we will have listed in the VFX reference platform for next year. So to cover the new features in the upcoming 2.1 release, first of all, we have the new ACES 1.3 Gamut Compression transform, and Carol will be speaking more about that in a few moments. Next, we have a set of OpenFX plugins, and this was contributed by Michael Dolan, who, in addition to chairing our TSC meetings and our working group meetings, is also one of our lead developers. So thank you very much, Michael, for that. The OpenFX plugins are, we did 2 of them to start. So basically color space transform and display view transform, which are sort of the key ones. If anyone is interested in contributing more plugins for look transform or names transform and so forth, that would be a great, good first issue for someone to tackle. Next feature is we are making updates to be compatible with the latest changes in OpenEXR and IMath. Michael is also contributing that work. There's a pull request currently in progress for that. Remy Achard from DNEG has contributed Python wheel, or Python package installer support. In other words, you'll be able to do pip install and get the OCIO Python bindings, which will be super useful for a lot of people so that they don't have to compile OpenColorIO from source. And finally, we have some work on open shading language, or OSL, and I'll talk about that a bit in the next slide. So we're very interested in collaborating with other ASWF projects, and 2 of them that we wanted to start with are open shading language and Material X, and hopefully we'll be able to do more over time as well. Patrick has been working on adding OSL support to the GPU renderer class, which is a natural fit since OCIO already generates similar shading languages such as GLSL and HLSL. So we're working on that for 2.1. There will be some caveats, and that's why I called it sort of preliminary support. The first release will not support color spaces that involve LUTs. Now, fortunately, with the new features in V2, there is not as much of a need for LUTs. So a lot fewer color spaces actually involve LUTs now, but that will be a limitation. And also, since it will be coming in kind of late in the release cycle. We may need to do some fine tuning in a 2.1.1 release later in the fall, but we think this would be a nice collaboration that will allow us to do some prototyping of support for OCIO in Material X. And with that, I will turn it over to Carol Payne to talk about the gamut compression work.
Yeah, hi everybody. It's really nice to be here today with all of you. In addition to being on OpenColorIO's technical steering committee for the past few years, I am also co-chairing the ACES Gamut Compression working group with Matthias Scharfenberg, who's also in the audience here. So if you say hello in the chat, Matthias, we'll be able to answer your questions about it. So gamut compression, we've all seen these issues. They're often caused by narrowband LED lighting that produce highly saturated, bright colors that your camera just doesn't know how to handle. Think cop car lights and neon signs, in addition to the examples on this slide, which are all without the gamut compression. So you can see in these magenta shades, these lights that are looking super crushed and out of gamut, and then the nose on the pig that's just awful. These issues stem from the input device transform into ACES and are further exacerbated by transforming to the smaller gamut of AP1. These issues, which often appear as negative RGB channel values in AP1, cause lots of problems for compositors and colorists, and they can be tricky to fix without affecting the entire image. The released algorithm can be thought of as a sort of successor to the previous release of the blue light LMT, which is in ACES 1.1, but it's a lot smarter. So this algorithm only compresses out of gamut pixels, leaving those inside the safety gamut formed by the boundaries of the color checker 24 values untouched. So it's kind of awesome to see this work come to fruition. It was released in ACES 1.3 and has now been added to the master branch of OpenColorIO to be released with ACES 2.1. If you could go to the next slide for me, Michael. Thank you. This amazing work was done by Remy Achard from DNEG for the reference implementation. We also want to thank all of our working group contributors and the OpenColorIO community. It's really great to see this feature added into OpenColorIO so quickly, in addition to all of the other built-in ACES transforms. So this transform is implemented like the other ACES transforms as a fixed function, which is called by a built-in transform. This fixed function is the parameterized algorithm, while the built-in transform applies the reference implementation parameters, which is set by the ACES release. It'll be available for applications as they upgrade to 2.1, and it's also going to be in our new ACES reference OpenColorIO config, which Michael will speak about later. So you can see in these images here, you've got your befores and afters of what's going to be available in OpenColorIO 2.1 to help with a lot of these pesky gamut compression issues. And with that, I'm going to hand it back to Michael to talk about our working groups.
Thanks so much, Carol. So I mentioned earlier that, and actually last year at our Open Source Days talk, we talked about forming two working groups within OCIO, one to look at the next generation ACES config for OCIO v2, and the other to talk about creating some user experience guidelines for application developers implementing OCIO. And so I'll give an update on kind of where we're at with those. We've been actively meeting for about a year, and many have participated. So thank you to everyone who's participated. So the config working group, the ACES configs for OCIO v1 have been widely adopted and used, and they're an excellent way to get OCIO implemented into a studio pipeline. They're large, and there's a lot of, a large number of color spaces. And so we really had a lot to take into account when looking at what it would mean to recreate a similar config and to support the various needs around that. And so really our objective was to build the next generation of that config for OCIO v2. And we had a number of goals from the start that we wanted to address. So one, we wanted to start from scratch. Rather than starting at the previous code, we felt that by starting from scratch with new code, we could license this code the same way OCIO is licensed with the BSD3 clause license. So that is what we did. There's a new GitHub repository, which I'll share a link to towards the end of this section, which is available for you to look at and to participate in developing. We wanted to make our config be generated with data from the upstream ACES dev repository. So ACES dev is where ACES is developed, and it contains all their color transforms, and each color transform has a unique ID which identifies it. So by mining that data, we could see what a complete ACES implementation looks like, and therefore we could maintain a full ACES implementation on the OCIO side, and be aware of when we need to update or make changes. And from the start, we also wanted this to be a joint collaboration between both OCIO and ACES. And so our first meeting we ever had was a meeting between leadership from both projects to look at what this might look like. And we've had active participation from both along the way, which has been excellent. And of course, a main goal of this new config is to utilize OCIO v2 features and conventions. Since OCIO v2 contains a complete implementation of ACES utilizing built-in transforms, which means they're implemented using algorithms rather than LUTs, we wanted to take advantage of that. And this helps us to reduce the dependence on external file transforms to have a more self-contained config and make it easier to modify and adopt. We also wanted to build our repository around good continuous integration and continuous deployment practices and versioning that would allow us to continue to validate the config to make sure that we're adhering to ACES and that we're not missing anything and that the quality is there. So we're still in progress with the continuous integration implementation, but the idea is that we'll use the ACES images to be able to validate that our transforms are matching their results. And then really another goal is to support user extensibility, to not just think about having a config that you just implement and that's that, but to really have almost more of a platform on which to build additional configs. And so the first effort was to create a reference config. And this reference config implements the ACES dev transforms exactly one-to-one and is meant to be an implementation of that. Something that we could even submit to the ACES logo program to become, officially support ACES. But its primary purpose is to track the accuracy of the OCIO implementation rather to be used in a production context. It's production capable, but it's not really complete enough for typical studio use in that it doesn't incorporate many of the color spaces around ACES that are used for typical production. So it's really intended to be a base implementation for other production-focused configs and to establish this platform. The config is 100% self-contained. It's a single YAML file with no external file dependencies. It's released currently and it's available on the repository, which I'll show a link to. You can download the config as an artifact. It's a great way for application implementers to test OCIO v2 and check out the new capabilities. And if you want to start developing an OCIO v2 config, you can use it as a starting point. Our next, and this diagram actually illustrates sort of our thinking behind how to structure this config. And so you can see here that ACES dev is providing ACES transform IDs, and OpenColorIO is providing built-in transform styles. And so what we have in our OpenColorIO config ACES repo is a CSV, essentially a spreadsheet, which maps ACES transform IDs to built-in transform styles, and then uses that to generate a config. And this is a little snapshot of that data. There is more columns and rows here that aren't visible, but you can see that we have the ACES URNs, which are the unique identifiers for the ACES transforms mapped to built-in transform styles. And this also establishes whether these would be implemented as color spaces or named transforms or looks, et cetera, and various other attributes in an OCIO config. So following the reference config, our initial goal was to develop a studio config, which would be essentially, the studio pipeline in a box and really be the next version of the current ACES config. But one thing we found along the way was that, for one, the studio config, it's very involved to create because it's very large and has a lot of input, but also that there was a need that wasn't met as well by that config, which is specifically working in computer graphics work where you're targeting rendering tools and game engines and lighting and texture pipelines, where you don't necessarily need hundreds of color spaces, but you just need more of the common texture and rendering and display spaces that would be used in a CG pipeline. And so we decided to create a CG config, which is focused on these specific spaces. There's no camera spaces in there. And so it's a very minimal config. It's largely contained. There's some file dependencies, which I'll explain shortly. But this is something that's derived from the ACES reference config and is built on top of it and allows it to be extended. And this would also act as establishing essentially the platform on which other configs could be built on top of the reference config. And so this config, the code for this config, which all of this code, by the way, is developed by Thomas Mensico from Weta Digital. Huge thanks to him for all his contributions to that. He's also been maintaining the previous version of ACES config, so it's really awesome to have that continuity of ownership of this code, and he's done an excellent job. And so that there's a pull request currently that has this config in it. We're still working on some of the underlying transforms. But if you're interested in participating, there's plenty more work to do. And here's kind of a look at how the CG config is organized. So where we had the reference config CSV data, which maps ACES transform IDs to built-in transform styles, that acts as a base implementation of the reference config. So for the CG CSV data, we can simply reference ACES transform IDs from the base implementation, and we can use that to inherit ACES transforms that are needed for the CG config. And then additionally, we introduced a CLF transform ID, which was created specifically for OCIO, but it acts as a unique identifier for a CLF or common LEP format implementation of the additional color spaces that are needed. And we decided to utilize CLF here for a number of reasons. But one is, we could have implemented these transforms using OCIO ops directly in the config, but we felt that using CLF would allow these transforms to also be usable outside of OCIO with things like the ACES metadata file. And it again, it helps establish a platform of how we can make this config extensible because CLF is fully supported by OCIO v2, and it's just a great way it can contain lossless ops essentially for OCIO. And so this CSV data is generated from the underlying ACES reference data along with these CLFs, and that's kind of where that config originates. And here's an example of some of that CSV data. So you can see we have transform names, which are either mapped to an ACES transform ID or to a CLF transform ID. And the next step of this is going to be continuing this effort with the Studio config, which again will be a full ACES color pipeline that studios can plug in and use and add to and modify as needed. We're planning on building this on the same platform that the CG config is built on, which again is taking that reference config and filtering out the ACES spaces that you need and adding additional spaces through CLF files. This will be essentially the replacement for the OCIO v1 ACES config. And because of the way the platform is designed, it makes it really accessible for studios that want to add in additional spaces to do so fairly simply just by modifying that CSV data and providing their own CLF file transforms, which again can be fully implemented in OCIO v2. You can basically extend this as needed. And so this config will use a fair number of external file dependencies. And it's going to cover most aspects of a studio pipeline. The one area we've decided to leave out for now is handling shot-based looks. Various studios handle this in various ways, and so we haven't yet reached a consensus on the ideal implementation that would work for everyone. And so our plan is to provide documentation on how different ways studios have implemented shop-based looks, and then it can be up to studios to implement as they see fit. But as we continue to evolve this work, if we do establish a consensus, that's something we could include in the future. And here's a diagram showing kind of the process behind this config, which you can see that it's identical to the CG config, except for one new piece, which is CLF files from camera vendors. And this is one thing we've started to discuss on this project, is that we really feel strongly that the best way to have accurate transforms for the IDTs and to support of the many cameras that are used in visual effects is to work directly with camera vendors. And so our intent is to establish a document that explains how camera vendors can implement their transforms in a CLF for use in both the studio config as well as in things like the ACES metadata file and other uses. And so we plan on publishing a specification that we can then work with camera vendors to provide CLF files. And the nice thing about this is it allows us to release the studio config essentially when we get it started, and then incrementally add support for additional cameras. And if there's a camera that's needed before we have support of it in the official repository, studios can, of course, implement that themselves and add it. So the new GitHub repo is called OpenColorIO config ACES, and it is under the ASWF GitHub organization. Again, Thomas is the lead developer of this project, and again, a huge thanks to him for his constant work on it, and it's really excellent. And so the reference config is available now, and the CG config is in a pull request and being actively worked on. And this working group is, again, still ongoing, so we'd love to have your participation if you have ideas and input, and even for other configs that we could support. The other working group we've been ongoing with is the UX working group. And this working group was formed really to help establish standards for how OpenColorIO can be implemented across all the applications that we use, so that when an artist goes from one content creation application to the next, there's a consistent experience and they don't necessarily need to relearn how to manage color on their work in each application. And so this group is formed of participants from software vendors. I'm currently chairing it with Mark Titchener from Foundry, and so we have active participation from Foundry and Autodesk and other vendors, and it's been a good conversation. And the goal really is to, again, educate app developers about how OCIO can be used, user stories of how artists use it, and then really work towards more consistent UX and UI across applications. And the goal to do this is to document these best practices in a document, which we can have be a part of the OCIO documentation online, but also can be essentially a published paper. And then this would also involve UI mockups and code examples to demonstrate this implementation in a way where it's easy for implementers to use. And we are also discussing and considering the possibility of developing an OCIO conformance program with the ASWF, which would be something like the ACES logo program, allowing developers to sort of have a mark that signifies that they're following the best practices for OCIO. We haven't decided to do this yet, but it's part of the conversation that's happening. And these are some of the topics that we've been covering with our guidelines. We have a working document that has a lot of these drafted, and we're continuing to work on them. But you can see it includes a lot of the new OCIO V2 features, which do add a lot of capability as far as how OCIO is implemented to create things like color space menus and how you handle missing color spaces and display and scene referred color spaces, context management, handling file IO, and OCIO based tools, dynamic parameters. There's a lot of topics to cover, and so we're trying to be exhaustive and having some input for all of these. And the goal, again, is to have this document along with UI mockups and OCIO app examples. As you're probably aware, we already have a number of OCIO apps which act as example code and as ways to test OCIO. But we want to take the opportunity to make sure that these apps are following the guidelines that get established. In particular, OCIO display will be a really important piece of this, because it's an opportunity for us as a project to provide a viewer which implements OCIO both with the GPU and CPU rendering, along with additional transforms that are common to viewers in a standard way. And it really gives an example to application developers of how to create their viewports in similar ways. And then this also includes the OFX tool examples that Doug talked about earlier, which can be used directly if your application has OpenFX support, or just be examples of how you can implement OCIO tools within your own application framework. So please do get involved. Really, you can help shape how OCIO is in the applications you use every day. We'd love to have your input, and it's been an excellent opportunity to just really bring together everyone's thoughts and opinions and ideas, and there's a lot of excellent input. So thank you so much for listening to our various presentations. We're now going to move into a time of Q&A, and we'd be happy to answer any questions or discuss any of these topics further. And you'll also find on this slide the links to our various channels for communication.
Yeah, awesome. Well, we have about 10 minutes-ish to answer your questions, and we don't have anything currently in the Q&A box. If anybody has any burning questions that they'd like answered, please feel free to throw them in that box, or I guess at this point, put them in the chat. And I guess at this point too, if we could, stop sharing and move to the that whatever window, thank you. And there we go, perfect. Yeah, so, but if there are no questions, I can definitely, make some up. I don't know if you just want to hear me blabbering or either, but we have one from David Morin in there around what the Conformance Program might entail. So we can talk about that a bit, other than it's very early stages, but sure. I don't know if Doug or Michael, if you want to jump on that.
Sure, I can talk about it. So we've been discussing this with John Murtek, who helps run ASWF's Linux Foundation involvement, and there's conformance programs is something that the Linux Foundation has experience with, and is a process of, we don't know exactly what it would look like yet, but we think that it would be, if we were to pursue it, essentially a list of standards that an application could adhere to, and then a process of validating that. It'd be more of like a self validation process to be able to say you have official support of all these features. So we're really open to exploring it. I mean, I think some of the input so far has been that that it would be a good opportunity to kind of help encourage consistency across implementations, but it's still really, there's a lot of discussion that needs to happen, and it's something that we would consider exploring after the UX guidelines document has been completed.
Awesome. Yeah, one step at a time. But we're excited about it and think that it could bring a lot of consistency for a lot of the users on the user end of OpenColorIO. Is a lot of what we're thinking about, is that consistency between applications and what to expect when an application says they have OpenColorIO implemented. The next question is, any plans or news on a metal implementation? That's a hot topic. Patrick, I saw you unmuted.
Yeah, so I'm muted. So for short term, we have no plan, but that's right that it's in the radar, because it's we receive some requests. So at some time we will investigate and see what to do with that. But on the other hand, it's an open source project. So if you have time and the will to do it, we are really open to help us, because as you can imagine, we cannot address all the requests, but this one is quite a good one to investigate.
Yeah, you'd be very open to collaborating with someone who has metal experience. And we could certainly provide the OCIO experience needed to make a successful collaboration on that.
Yeah, and there is open issues in GitHub for Metal already, as well as for CUDA. So, any of those other, support for rendering would be awesome.
Yeah, I think that's a good plug for anybody curious on, what's currently, possibly already in development or being considered or things like that. Is to, Patrick posted in the chat our GitHub, and so you can check in there those open issues and requests and feature things and the comments made on them. So at any time, that's probably the best way to get on the radar, is to put an issue in on GitHub with as much information as you have, and we'll start tracking it that way. The next one is a fun one from Rob, around the conceptual difference between algorithmic and LUT-based transforms. Other than disk access and storage, what are the main advantages to change to algorithm-based transforms? Does it generate the same results 100% or just very close?
Yeah, that's been one of the advancements in OCIO v2 is we've added a number of operators that allow us to implement the math of the algorithm more precisely than a LUT. And so the accuracy of the ACES output transforms, for example, in OCIO v2 has increased a lot because in v1 they're implemented via LUTs, and a LUT has a finite range. So at some point you run off the top of the LUT, and so if you have like an HDR image that you're using for an environment map or something that has very bright values, they might not be accurate. And so it also allows us to move away from files. So as Michael mentioned before, the new ACES config does not require any external files for the reference config. So it makes it more portable, and it also makes the configs more compact and easier to read. So we definitely try to take that approach to move away from LUTs wherever possible.
Awesome. There's another question around ICC profiles, and that's something that was also introduced in 2.0. I'm wondering about if that's actually, well, it is in 2.0, and there's a question from Chris around if there's support for handling embedded ICCs in image sources and what our thoughts around that are.
That would be interesting. Right now, there is no support for extracting metadata from image file formats. That is it would be an interesting future area of development. We'd have to figure out, what is the best mechanism to open and parse those files and extract the metadata. Like, would the client do that, or would OCIO do that? But yeah, certainly that would be an interesting future project for someone.
Awesome. Another question that is definitely a hot topic right now around image viewers from Stephen. Might OpenColorIO and OpenImageIO consider collaborating on a first-class viewer application which has all of the bells and whistles, and sort of rejuvenate an image display viewer that could be powerful and open source, is the way I'm interpreting that question.
We of course work a lot with Larry and OpenImageIO on the current integration between the projects, and in our conversations of supporting OCIO display, including in the UX working group, there has it definitely has come up in the conversation, as to, does it make sense to put that into OCIO display, or should we be looking at the IV viewer that OpenImageIO provides? But I would say, as just a general interest point on the subject of image viewers, is that there is an ASWF working group on review platforms. I don't recall the exact name of it, but that is one of the main topics that they are looking at addressing, is like, what is the open source review software look like, and what makes sense to what's the future of that. And so I know that's one of the main points that they've been discussing, and so it'd be a great place to hear more. But I mean, I think one of the really cool things about the ASWF is just how it's brought a lot of projects together. And just looking at the projects that are currently a part of the ASWF, there's a lot of the pieces to a robust image viewer or review pipeline that could be leveraged between the projects. And so I think there's definitely some great opportunities there to pursue in the future.
Awesome. I want to point out that Larry's noting that OpenImageIO does have a viewer. It definitely, like all other open source projects, has a lot of work to do and always is looking for motivated volunteers. If that's an area that interests you, please feel free to look around and contribute where you can. And the note of that ASWF working group is the review and approval working group, which I believe has a session today or tomorrow. Don't quote me on that. I think I saw it on there. But yeah, it's a really great question and a very hot topic in the industry right now is consistency in image viewers. So definitely stay tuned around progress from the ASWF on that front. And I think with that, we are just about out of time. Any last thoughts from Michael, Doug, or Patrick?
Check out our Siggraph course next week.
Yeah.
And we'll be doing a live half-hour Q&A session on Monday afternoon.
Yep.
Yeah. And
Awesome.
any further questions, feel free to jump in our Slack workspace, and it's a great place to continue the discussion.
Yeah, sorry we didn't get to all of the questions, but we'll be happy to answer anything offline and in the future. Thanks, everybody. Have a great rest of your conference.